Okay, so in this video I'm going to be going over a few demos that exemplify the progress I've made on the geometry solver. So what I've been able to do is implement the facilities to get my solver to be able to calculate all geometrical properties of any triangle. And so I'll show you a few cases in which the solver actually solves a triangle. Okay, so I haven't implemented any graphical user interface, so the way that we're going to define the triangle is actually just hard-coded, and so all the geometrical values are kept in a dictionary called top here, and each entry represents property of the triangle. For instance, A, B, and C are the angles, the three angles of the triangle. SC1, SC2, SC3 are the line segments. AR is the area. V1, V2, V3 are the vertices of the triangle. And so in this first demo here, I'm going to show you a case in which only the vertices of the triangle are defined here. As you can see, all other characteristics are not defined, but the vertices are defined. Essentially, we should be able, the solver should be able to find the rest of the characteristics given these three vertices. And so we're going to run the code now here. And so again, don't have any graphical user interface yet, but we can still print out once the solver is done calculating. And as you can see, we have A, B, and C, the angles again, and we have all of the characteristics printed out and defined in the terminal here, so we know that this works. Okay, so I've set up the next triangle that the solver will solve, and so in this case, instead of the three vertices being defined, they are now undefined, and what's defined is a single angle here and two lengths of line segments. Now, since no vertices are defined, there's no way that the solver will know what to figure out the vertices, but what the solver can figure out is the area and the rest of the angles and the remaining line segment that's not defined yet. And so I'm going to go ahead and run the code here, and here is our output down here. We see we have the three angles defined and our three line segments in the area. And so if you want to notice here that A is our angle, and we're using pi over 2, which is 90 degrees, and we have two line segments that are lengths 1, and this is essentially a 90-degree triangle with the height and width of 1, and we know that the formula for the area of a triangle is length times width over 2, and so that's 1 times 1 over 2, which is the area that we found, which is 0.5. So you can verify that the output is correct.